It's been said that form should follow function, and that's especially true in the petroleum industry. Petro-Canada's RCP delayed coker structure had specific demands for its function.
The new coker that we were building was literally 50 feet away from the existing coker that was in operation 24 hours a day. We had to be very cognizant of issues that were going on in the refinery. We had permits, we had meetings that we had to do with our operations personnel on a daily basis to ensure that we weren't impacting what was going on in the refinery.
The structure itself is 330 feet above grade. It sits on a concrete pedestal which is 80 feet above grade, with the remainder being the steel structure itself. The modularization of this structure was done in 25 components. 9 were done as what we call pre-assemblies, which were done very close to the Petro-Canada refinery site, and the other 16 were done off-site in what we call modularized components.
It was a big success because of the declining crude diet that we've got in terms of light conventional crude. This really sets Petro-Canada up in the Edmonton refinery well into the future for running a crude stock that comes from the oil sands, and really fits with our future there in terms of what our project plans are as we move forward.
The Petro-Canada RCP delayed coker structure is a fine example of form following function, making it an admirable finalist for the CISC Alberta Awards Industrial category. Production of liquid oxygen for industrial use is a straightforward procedure. Producing it in large quantities requires a large airtight structure. The ASU cold box is the largest structure of its kind in the world.
A cold box is the heart of an air separation unit. The air separation unit is part of an oxygen production facility. What it does, it takes the air, compresses the air and cools it down, and then put it into this air separation unit to separate the components of the air, and then we liquefy the oxygen. And this is what this plant produces. For this particular case, the cold box is 8.5 meters by 10 meters by 64 meters tall. It is by far the largest we've ever done, and it is part now of the largest oxygen production facility in operation in the world, and that's in Fort McMurray.
I remember taking a picture of the cold box in the first L when it left the shop. And we have fairly high clearances, and the base plates were just clearing the top beams, like the underside of our trusses. After the fabrication of the box, we sent it to site, and they erected it, and from what I heard on site, they had no problems. I think there was something like 6 bolt holes out of many thousand bolts that did not line up.
The fact that we had to design this whole box and then cut it all into all these small pieces to be able to ship it and then put it back together like a giant jigsaw puzzle, I think is what sets the project apart.
The use of steel to construct the ASU cold box ensures it has the airtight seal and other characteristics necessary to meet the massive demand. It's easy to see why it's a fitting finalist in the CISC Alberta Awards Industrial category. Time, or the lack of it, seems to be a constant in the construction business. Solutions are needed in order to meet demanding deadlines. Steel is often the answer.
Alta Steel is in the midst of building a reheat furnace when they needed to build a basement essentially for the reheat furnace, which required them to excavate about 30 feet down into their pit. In doing so, they uncovered some unfavorable soil conditions where they were stuck with a bunch of water seeping into their excavation. They needed to reinforce the tops of the sheet piling with the whaler truss system. And after these whaler trusses were installed and holding back the retaining wall, we were able to bring in 3 excavators and from there dig to the bottom of their basement.
The components that we could salvage, basically anything 20 feet and longer, we did, and we'll plan to use that in future projects. That which we could not use in that way, we just turn it into scrap and it goes back in the furnace and it turns into new steel again.
A solution for any industrial application can be found eventually. Solutions with deadlines are far more challenging. For meeting the demands of a time-critical project, the Alta Steel Whaler Truss is a commendable finalist in the CISC Alberta Awards Industrial category.